Okay, good morning, afternoon, or evening, everybody. Welcome to the Advancing Ecological Insights with NASA Subsetting and Visualization Tools and Services for Site-Based Research Earth Data webinar. This is your host, Jennifer Brennan. It is 2 p.m. Eastern Daylight Savings Time, so we are going to go ahead and get started here. What I will do is I'll begin today's webinar with just a few logistics. To ensure the best audio experience, all participants have been placed in silent mode. But if you have any issues or you have any questions, what I'd like you to do is enter those into the Q&A panel, and you should, rather than the chat, and you should see that on the right side of your screen. Today's webinar is being recorded. The recording will be posted both to the NASA Earth Data website as well as to our NASA Earth Data YouTube channel within a week of completion. Once completed, I will send an email to all registrants with recording links and also a link to the presentation slide deck used within today's webinar. As far as timing is concerned, today's webinar will be 1 hour long with 45 minutes allocated to the presentation and live demonstration and an additional 15 minutes for the question and answer period. Depending upon how many questions we receive, we may extend that Q&A an additional 15 minutes from end time. During today's webinar, we have two speakers. Our first speaker is Dr. Bruce Wilson. Bruce is the group leader within the Remote Sensing and Environmental Informatics Group at Oak Ridge National Laboratory Environmental Sciences Division, and he's also the NASA ORNL Distributed Active Archive Center, or ORNL DAAC manager. He will begin today's webinar. Let me actually pull up excuse me for a moment, the agenda. He will begin today's webinar with an introduction to NASA's ORNL DAAC and also provide an overview of the Terrestrial Ecology Subsetting and Visualization Services, or TESVIS, tool suite. From there, we will transition to our second speaker for this afternoon's webinar, Dr. Rupesh Shrestha. Rupesh is a research scientist at NASA's ORNL DAAC, and he's also an adjunct assistant professor within the Department of Forestry, Wildlife, and Fisheries at the University of Tennessee, Knoxville. He will take us through the remainder of the webinar by providing more in-depth information about the TESDIS tool suite and the available data sets with a focus on recently added data products. And then from there, transition to a demonstration of the NASA ORNL DAAC's fixed sites tool, the global subsetting tool, and the REST web service. And then finally, what we'll do is we'll wrap up this afternoon's webinar with a Jupyter Notebook demonstration that'll show you how to create GeoTIFF grids from a subsets response. Excuse me. Once Rupesh has finished with his presentation, we'll then transition to an optional final set of polls, and I will leave these questions open for about 30 minutes or so that you'll have time to provide your response as we go through the Q&A. Depending upon the volume of questions, again, that are received, we will extend the Q&A period an additional 15 minutes from end time for those of you who wish to stay on the line, but we will have a hard cutoff of 3:15 p.m. And just one final note about Q&A, we do have quite a significant registration for this afternoon's event. We will try to answer all of the questions within the time allotted, but if we are not able to address your question during the Q&A, our speakers will be able to follow up with you offline. With that, it is my pleasure to introduce today's first speaker, Dr. Bruce Wilson. So at this point, I'm going to stop sharing and toss my role over to Rupesh, who will share. Rupesh, great. And I will open the polls so that you all, for those of you who are interested, you can actually provide a response to these. So let me open these polls up here. Okay, you can go ahead and get started. Just give me 1 second with the polls. Thank you.
Great. Hello, and thanks for coming to this webinar. As Jennifer indicated, I'm Bruce Wilson, and I get to serve as the manager for the Oak Ridge National Laboratory Distributed Active Archive Center, or ORNL DAAC. I will provide the first part of this webinar. My colleague Rupesh Shrestha will do the second part. So The purpose of today's webinar, we're going to be talking about some tools that help people gain ecological insights, particularly for cases where the interest is in a specific location, such as researchers who have a specific study site. Next slide, please. Jennifer's covered this outline. So as she said, I'll give the introduction, give a little bit of some overview of some things, and then give the floor to Rupesh, who can then dive into some of the details, some of the recent additions, and so forth. Next slide. We have mentioned the NASA Earth Observing System Data and Information System, or EOSDIS, and an important part of EOSDIS is the 12 Distributed Active Archive Center, the 12 DACs that are shown here on this slide. Each of these DACs has a particular focus area, as we've shown, and you can find more information about the DACs at the Earth Data website URL that's on this slide and which Jennifer is making available to folks. So Rupesh and I are from the Oak Ridge National Laboratory DAC, the ORNL DAC in specific, and our focus is on terrestrial ecology, but in particular, we work with field ecologists and data from those kinds of studies. Next slide. So we archive and distribute this terrestrial ecology data, particularly data from these field campaigns and airborne campaigns. There's a link there to our website on this page as well. But in addition to archiving the data from these field campaigns, we also have a role of helping these kinds of scientists access and use remote sensing data. And that role, helping scientists access satellite remote sensing data, is the focus of this webinar. Next slide. One more. There we go. So what's the need? What are we trying to deal with here? So this photo that's at left from a Carboscale project overview paper, again, link is there to provide credit to the folks for this, is an example of one type of research environment. And in fact, it's the type that was the inspiration for the tools that we're talking about. And in this example, we have a flex tower at a particular location, and that tower is measuring a variety of variables, including temperature, wind speeds, atmospheric composition, how much CO2, how much oxygen, as a vehicle for trying to understand the net ecosystem exchange, how much carbon is being taken up, how much carbon is being released by a given ecosystem, a given area. And what it's sampling is going to depend on the winds and a variety of other factors. But if you look at the scale on this graph, you can see where there's 500 meters there. So order of magnitude, we're looking at a little bit more than a square kilometer. And that 1 square kilometer is about the same size as a single pixel in a number of remote sensing products. In fact, many of the remote sensing products from the MODIS or the VIIRS tools are at this 1 kilometer or maybe half a kilometer, quarter kilometer kind of resolution. But they're also arranged in these tiles, which are 1,000 kilometers by 1,000 kilometers. So if I'm looking and going, say, a little bit broader, a 7 kilometer by 7 kilometer study site really only represents 49 parts per million. And sorry, I'm a chemist, so parts per million is a natural unit for me. Of the data that's in a single MODIS tile. So a user would have to download a whole bunch of data to just get a little bit that they're interested for studying a particular site. And furthermore, the data is in this HDF EOS format, which a lot of people know how to work with, but it's also outside of the expertise for a variety of people. So we make this data available in more common formats like CSV, common separated value, and JSON, JavaScript object notification. We also can go a little bit further and say, well, people may actually just simply want to look at the data. And so we provide some tools to be able to display graphs of the time series and allow people to interrogate the data and say, is this actually data that I want to see? Is this data that's actually going to be helpful to me? And it's gratifying for us when we see these kinds of graphs show up in papers, show up in posters at places like Geophysical Union conferences. So this is what we're after here. Go ahead, next slide, please. And this leads to what we are now calling the terrestrial ecology subsetting and visualization services. You may have heard of these as the MODIS tools or the MODIS VIIRS tools. And if you look at the URL at the bottom right, you'll see it was modis.ornl.gov. And that's what they were called because when we started with these tools back in about 2003, it really was just MODIS. We got some specially prepared subsets of selected MODIS land data products that were provided to us by the MODAPS, the MODIS Data Processing Facility, and we made those data available. We expanded our capabilities to provide on-demand subsets, added in some additional fixed sites over time, developed some web services, added more sites, added more data products, expanded out beyond MODIS. Next slide. That's led to some recognition for this tool, including this particular award. I think the biggest recognition from our perspective, and I'll talk about it a little bit later on, is the number of ways that we see these tools being used, particularly in the science literature. Next slide. So where we are today, there are 49 different data products. 48 of them are satellite remote sensing. One, DAMET, is a reanalysis product that's produced by the ORNL DAAC. We included that. Most of these are gridded data products. But Rupesh is going to talk about this a little bit more. Some of the GEDI data products and the Atlas ISAT2 data product are actually footprint level. So there's some interesting challenges in trying to integrate these different kinds of data sources. Next slide. So what does TESVIZ, what do the MODIS VIIRS tools do? They quickly provide subsets of these satellite data in easy to use formats, and they're particularly valuable for people who are doing site-based research, who are interested in fairly specific areas of time. Next slide. It's divided up into three different tools. There is the global subsets, which is a way to get a subset up to 100 kilometers by 100 kilometers on a side for any location on the Earth. There's the fixed sites subsets tool, which is where we've already prepared cutouts for about 3,000, 3,300 sites around the world where we know the data is being collected, sites of research interest, and that includes, for example, 1,145 known sites in the AeroNet network and 854 different sites in the FluxNet network of networks. And those are great tools for people to work interactively, but we also have a web service for those of you who are writing scripts who need to be able to access this data programmatically. Now, the global subsets tool is organized and was really inspired by this Flux Tower model. So the way a location is specified is by giving the latitude and longitude of the center point, and then how much data are you interested in north-south, and how much data east-west. Next slide. I mentioned fixed sites, and here's a screenshot from there from a few days ago, and it illustrates there are 50 different networks where we're talking with those network providers to understand when have new sites been added and so forth. And we started with a few hundred sites 20 years ago, and as this shows, we're well over 3,300 now. And the key point is this framework. I like to give credit here to Dr. Ann Shaka. She was the one who brought this to me in her former life when she worked for Lubrizol. She's now at Pacific Northwest National Laboratory. We're really interested in trying to provide these results immediate, in the case, say, of the fixed sites tools, but at worst in this sort of over coffee time frame, worst case over lunch. And then, when we're backed up and we're dealing with a lot of people, a lot of requests, things do sometimes take overnight, but we're really after this over coffee time frame. So next slide. If you walk through at modis.ornl.gov, let me just give a quick overview. Get Data provides you links to the subset tools, global, fixed, and the web services. Next slide, documentation. So this is a complete listing of all of the data products, and you can see which products are in which service. Most of them are in all of the services, but again, sometimes there are some challenges in integrating very different data, and we only make them available in a few services for a few cases as we understand how to make sure that we're presenting that data correctly. Next slide. Some resources, some learning materials. This webinar will wind up being on those learning resources after it's posted, but you can see some classroom information, other learning resources, community tools that are available to you. Let's talk about publications, and I looped to this a minute ago. We've found a little over 700 publications that are citing the tools themselves. We really do appreciate when you're able to cite the tools as well as citing the data that we provide. Next slide. And we give you some tools in order to be able to do that. Here's the citation for the tool set, and the order will also provide you with some information about the citations for the data that has been provided. So with that wrapping up my introduction, let me turn the floor over to Rupesh, and he will talk more with the new data and how to work with it.
Thank you, Bruce. So now I'll go into more detail about the tools. So I'll provide an update on the new datasets we have recently added, such as MODIS Collection 6.1, ISAT2 ATL08, and GEDI higher level products. And I'll also give an overview of the features of the tools, the global subset tools, the fixed size tool, and the associated APIs, followed by a demonstration of the tool. And I'll end the webinar by providing a brief Jupyter notebook and using the data from the subset tools. So MODIS is on board NASA's Terra and Aqua satellites and has been acquiring data since 2000, offering 20 years of consistently produced land product data. So MODIS has been a kind of like gold standard of all NASA's missions. It has been more impactful in enabling tens of thousands of peer-reviewed publications. In the subset tools, we have upgraded MODIS collections from collection 6 to now collection 6.1. So this is now available for 31 of the 32 MODIS products that include Terra, Aqua, and combined products. So now that processing of collection 6.1 products is complete, the MODIS collection 6 is retired, and you are advised to migrate to collection 6.1 if you haven't done so already. So the improved collection 6.1 addresses several issues in collection 6 for level 1B products, so which also enhances downstream level 2 and level 3 products. A detailed summary of changes is provided in this document link here. More information about MODIS mission and data products is available in this website here. So one additional note about Terra and Aqua is that after being on orbit for so long, so which is far beyond what was initially planned. So they are starting to drift the orbits and will run out of fuel and be decommissioned soon in future. So these charts show when such change in drifts will happen. So one impact such drift will have is to the time when the satellite crosses the equator. For example, Terra will continue to cross the equator earlier than 10:15 a.m. and Aqua will cross the equator later than 1:45 p.m. So this will have impacts such as longer shadows in the mountains and also changes in the swath width. To learn more about this orbital drift, how this will impact your science, please visit this website here. So when MODIS eventually stops collecting data, continuity can be achieved by using the VIIRS product. The VIIRS is on board Suomi and PP satellite, a joint partnership between NASA and NOAA. So VIIRS continuity to the MODIS mission is provided by extending and improving upon the MODIS measurements. So the VIIRS land products use similar algorithms to the MODIS products and are produced in the same graded system and temporal frequencies as well. So we have now 3 satellites so far that have VIIRS instrument on board. SNPP launched in 2011, JPSS-1 launched in 2017, which is now called NOAA 20, and JPSS-2, now called NOAA 21, launched only last year. So there are more missions planned for the futures as well. So the currently available NASA VIIRS land product are from Suomi and PP So that provides more than 10 years of data overlapping with MODIS. So a subset of VIIRS collection 1 products are available in ORNL DAAC subset tool. So we have recently added VIIRS phenology products as well. So collection 1 includes data from VIIRS on board SNPP, but the collection 2 is being planned for release in the near future. So the collection 2 will include cross-calibrated data from both SNPP and NOAA20 as well. The more information of VIIRS mission is provided here in this link. So most MODIS and VIIRS continuity products are natively available in MODIS sinusoidal grid. So the data for each time period is tiled into approximately 10 by 10 degrees. And you can learn more about MODIS grading system here at this link. So we have also provided a KML file you can download to learn more about the grading system. So the tiling for the MODIS results in a smaller file size, so which is great and easier to work with, but also adds a layer of difficulty for users. So when the area of interest, for example, falls across multiple tiles, the ORNL DAAC subset tools make it easier to retrieve such data sets. So in addition to the complexity created by tiling, the MODIS and VIIRS dataset comes with quality flags that must be applied to retrieve good quality data values. So these quality flags come in bit integers and often harder to decipher for especially non-technical users. So the ORNL DAAC subset tools applies the default quality flags recommended by the science team and provides a very usable quality filter data set. So if you want to learn more about quality filtering of these MODIS and VIIRS products, please refer to the resources page at this link here. So this table shows a summary of MODIS and VIIRS land products available in the ORNL DAAC tools. As you can see, these cover a range of variables important for ecological research. So the data products, namely starting with MOD are Terra here. So those starting with MYD are Aqua, and those starting with MCD are combined Terra and Aqua products. And VIIRS starts with VNP. So as you might have noticed, VIIRS does not have continuity products in some categories, such as evapotranspiration and land cover type. So we'll continue adding them to the tools as they become available in future. So as more data sets migrate to NASA's Earth Data Cloud, so our workflow for adding these new data sets to the tools will also become more streamlined in future. So traditionally, ORNL DAAC subset tools provide subset for only graded products. So recently, as Bruce pointed out, we have added 2 new non-graded products. One is ATL08, photon-level canopy structure dataset from ISAT2, and the other is level 4A, footprint level above ground biomass dataset from GEDI. So Atlas instrument on board ISAT2 is a photon counting lidar and measures the surface of the Earth. So it was launched in 2018 and has been collecting data for more than 4 years now. And Atlas collects data along 6 tracks grouped into a pair of 3. And these 6 ground tracks make about 6-kilometer wide path along the flight direction. And it has a repeat rate of 91 days. So more information about ISAT2 instrument are available in this website. So this diagram on the right shows a range of current and planned data products from ISAT2. So we have recently added the subsetting capabilities for ATL08 to the ORNL DAAC global subset tools. The ATL08 dataset shown here in the red circle is essentially a filtered version of ATL03 dataset. So ATL03 provides the heights of each photons, and ATL08 algorithms separate these photons into noise, vegetation, and ground. So as shown in the chart here in the bottom, ISAT2 photons are really noisy, and successfully retrieving ground and vegetation signals from these noisy photons requires a sophisticated approach, such as the one applied by ATL08 algorithms. So ISAT2 data is natively available in SDF5 format. So more details about products are available in this link. So one other note is that some files in the current version 5 of the ATL08 are affected by some geolocation error. A new and improved version 6 is being planned for release at the NSIDC DAAC in the summer of this year. Other data product we have added to the subset tool are from GEDI. The GEDI is a high-resolution LiDAR mission launched to understand forest structure, mainly tropical and temperate forest. So it was launched to the ISS International Space Station in December of 2018, and it has coverages ranging from 52 degrees north and 52 degrees south latitudes. So more information about GEDI mission is available at the link here. While ISAT-2 uses photon counting LiDAR, GEDI uses a full waveform LiDAR with about 25-meter footprint. So ISAT-2 had 6 tracks, and GEDI collects data in 8 tracks with its 3 near-infrared laser sensor covering about 4 kilometers of ground width. So there are 4 coverages beam and 4 full-powered beams. So we have added subsetting capabilities for level 3 and level 4 datasets in the ORNL DAAC subset tools. So level 3 provides canopy metrics, and level 4B provides Aboveground biomass as a graded products natively as geotips. And level 4A provide a footprint level non-graded Aboveground biomass. It is available as SDF5, similar to ISAT-2 ATLO8 dataset. So more information about GEDI products you can find in the link here. As Bruce pointed out earlier in the overview, the subset tools are a set of 3 integrated tools: the global subset tool, the fixed site tool, and the web service or application programming interface, API. So I'll now go into each of these tools and demonstrate their capabilities. The first is the global subset tools. So it allows to create a subset for user-defined locations and extent. So this relies on email delivery of the order. That means that there is usually a wait period between when the order is submitted and when the order is delivered. So the tool is available at the link shown here. So you need to be logged in using NASA's Earth Data login before an order can be submitted. So if this is the first time you are using a NASA Earth Data system, a new Earth Data login account can be created by registering at this URL. So once you have the user ID, you can log in here. Let's log in. So once you log in, so we can add the locations of interest. So let's click the Add Location button here. So you can now provide the coordinates of your location and the size of the subset area. And you can also use this button called Use My Location. So it'll use the coordinates provided by your mobile device, for example. And this feature enables you to place the subset order in the field when you are collecting other field in situ dataset. So when you are back to your lab, the subset order are already processed and ready for you to start working with. So if you click in this Upload Location tab here, you can input the location as a comma-separated CSV file or a GeoJSON format as well. So you can input as many as 100 sites in a single order. The samples file are provided here for both CSV and GeoJSON. So let's click on Add Location here. And then now all your sites will be visible in this map here. So you can further edit the locations by clicking on these green edit buttons, or you can add or remove more site delete button. And then the next step would be to select the products you want the subset for. So you can select as many products as you need. And to make it easy to find the right data products, you can also filter the products by sensor or products by variables, as shown in the bottom here. So you can now select the start and end date and the projection system. So currently 2 projection systems are available, giving you the output geotip file in the selected projection system. And then you can now submit the order. So upon submission, so it'll give you an estimated time for the order to be completed. So like is shown here, it's saying 74 minutes to complete these 4 orders. So this estimate is approximate and is based on the previous orders for the same subset size, duration, and the product selection. And you'll also get a unique ID for your order for all of the 4 orders that you have submitted. So once the order is complete, so you'll receive an email like this notifying you that subset order is now ready. So it also provides the suggested citations for the data and the tool. And clicking on this Access Order button will take you to the order delivery page. So you can also view the order status on the history page. The link is provided here. So the history page will show you the time remaining for each order or whether the order has been processed. So you can also access all of your past orders by clicking on the order IDs in the first entry here. So we only keep order for about 1 month period, and we usually delete any orders that are older than 1 month. So the order, if your order is older than 1 month, it will not be clickable. So there is also an order map to make it easier for you to find your past orders. So this is a typical order delivery page. So this page will vary depending on what data set you are ordering. And this particular one is for the MODIS NDVI dataset, MOD 13Q1. So this page can be viewed without using your Earth data login. And you can share it with your students, collaborators, or others. And the top is the download section here, where you can download the raw data set, quality filtered, and a scale data set, and statistics. So the table here lists the data only for the science bands, but other data bands and statistics, phenology, and land cover can be accessed by clicking on the CSV data here at the top. So in the table, this table, the right column lists the data with the land cover mask applied, meaning that pixels different from the land cover to that of the subset center are being masked out. So in the top here, you can also see citation and the quality controls tab. The quality control tabs might be particularly helpful in understanding which filter was applied and which was suppressed. So this one shows 2 has been presented and 2 are suppressed. So the next section here is the time series visualization. The blue lines are the central pixel of the subset area, and the red lines represents the average of your subset area. And you can also visualize with the land cover filter applied. So this will show you only the time series for only the selected land cover in your subset area. You can also stack the time series by year if you want to compare between years, for example. So this is an example order delivery page for ISAT ATL08 dataset, so which looks somewhat different from the delivery page of the MODIS VIIRS subsets we just saw. The subset dataset is available in CSV, GeoJSON, and the native SDF5 formats, so which can be downloaded with this link. And a GeoJSON format is particularly useful for easily importing to a GIS software. And it also provides a visualization of the land segment canopy height. So you can click on each of these land segments represented by the color dots here, and it'll show the canopy height and the uncertainty information right here. So here the canopy for this area ranges from 2 to 35 meters. This is an example order delivery page for GEDI L4A footprint level biomass dataset for the same area. So as you might see, the delivery page and visualization look very much similar to ISAT2 ATL08 photon dataset. The subset data are also available in CSV and GeoJSON and native SDF5 format. Now let's look at the fixed site subset tool. The tool includes pre-processed cutouts of about 8 kilometer by 8 kilometer area for the field and flux tower sites. So because they are pre-processed, so these fixed site data are instantly available through web interface or API, and there is no wait period for the order to be processed like you have with the global subset tools. An example URL is provided here to show how to access a fixed site. So this is an entry page to the fixed site tools. So there are more than 3,000 sites, mainly from the networks such as flux tower networks and other validation and long-term monitoring sites. So we check these networks regularly for new sites, or if the location of a site had changed, and we update them accordingly very regularly. So Now let's search. There's a search interface here for the site called Tangi Ranch, which is one of the Ameriflux site in the foothills of California, USA. So a site page for the Tangi Ranch will look like this. This will list all the subset data products available for the site. And in the table, if you click on any of the product links, it will take you to the product page for that site. So this is the example product page. So this page is very much similar to the global subset tools order page. The first section is the download section where you can download in a CSV or JSON formatted files. And then there is also a visualization at the bottom here. Now let's look at the third tool, the web service for retrieving the data programmatically. So this is a REST-based API, REST, so which uses a much simpler protocol and allows data access using standard HTTP methods, such as GET requests. So the web service can be used to request data for a user-defined subset area or for the pre-processed fixed sites. So there is also a R package available, making it easier to retrieve subset data from the R environment. So this package, particular one, is developed by Cohen Hopkins of Blue Green Labs. So link to the package is provided here. So we have also developed a graphical user interface for testing the capabilities of the API. So these are available at the link provided here. So these are the endpoints available for the global subset tools API. The products endpoint here will return a list of products, and a product and subset request will return the subset for a location of the choice. So we can also pass sensor parameters to the products endpoint via GET request, and it will provide a list of products available. Here it is showing the response in JSON format for a VIIRS SMPP products available in the API. And you can also receive the response in the CSV by passing the header format like so. This shows the response in a JSON format from a subset GET request. So here we have passed the product, and there also is the longitude and latitude values and the start and end dates. And we also provide the subset size to this endpoint. So the products, latitude, longitude, start and end date, and the kilometer above and kilometer below. So in the output, there is a corner coordinates and the grid size provided in every response. So this information is necessary if you want to recreate a gridded file such as GeoTIFF from the subset data. The actual subset data for each date and band is provided within the data keys as shown here. Within the subset keys, the data is within the subset. And the bottom chart here shows the pixel numbering scheme for the grid. The blue box here in the middle is the central pixel, and all others are around it. So please refer to this link for more information on the data structure. So we have a similar endpoint available for fixed sites as well to get the information via API. So submitting a GET request to the site endpoints will give you the list of sites available in the fixed site tool. So in this example request, we are retrieving the list of Ameriflux sites for which the subsets are available, and you get all the information as well. And to retrieve the subset data for a site, you can pass the product parameters to the network site like so, that's shown here. So this is an example for the same Ameriflux site. And the output structure is very much similar to what we get from a global subset request as well. So now I will show a quick tutorial on how to build a gridded file such as a GeoTIFF from this API response. And I'll also create a simple visualization of canopy height from ISAT2 ATL08 dataset for the same area. So this tutorial is also available at the GitHub page shown in the link here. First, let's import the Python modules. So all the required modules are listed in the requirements.txt file, so which can be used to install the required modules by using pip, like shown here. So in this tutorial, we'll be retrieving a subset for VIIRS vegetation index product, VNP 13A1, for an area near a national park in Gabon, which is dominated by a tropical rainforest. So we'll request a subset area of about 20 by 20 kilometers. So let's first build the parameters. So this is the base URL of the API, and we provide the longitude and latitude information, as well as the band, which is enhanced vegetation index for this VIIRS vegetation product. And the subset size is also provided 20, 10 above and 10 below, next 20. So now using the parameters we just defined, so let's submit a GET request to the API and print out the JSON response. So here we are constructing the API endpoint, base URL, product, and subset. And we are then submitting the GET request using Python's request module and passing the parameters we defined earlier in this params variable. Now we can check if the request is successful or not. So if there is an issue with the request, this step will throw an error message. And so then now we are printing the output JSON response. So the response is similar to what we saw earlier in the earlier slide. And the information we need specifically to create a gridded file is highlighted here with the red. So we will need all these corner coordinates and the cell size and the number of rows and columns. And the actual data is provided in this data key here within the subset key. So now let's retrieve all the response information, the corner, cell size, rows and columns, scale, and the data. The subset data now is stored as a NumPy array. So as you can see in the printout here, the data variable is a one-dimensional array with 16 by 81 elements. So this NumPy array needs to be reshaped into correct rows and columns and properly oriented as well, so which we do here. As you can see, the data array is now a 41 by 41 two-dimensional NumPy array. So now let's define the projection at sinusoidal, which is the native MODIS projection, and also define transformation parameters, which we'll use to create a GeoTIFF file. So we'll use a raster IO module to create a GeoTIFF file. So in addition to GeoTIFF, raster IO also supports converting to NetCDF, SDF5, and other formats as well. So here we save the data NumPy array as a TIFF file. So we are passing here height and width of the image and CRS and the transformation parameters. So now to check if the output is correctly created, we can open the GeoTIFF file back and plot it here. The image here shows the enhanced vegetation index or AVI band for the area. The higher value here means it's more green than the other areas. So now you can use this GeoTIFF file to import into your workflows for further analysis or to a GIS software, for example. Now I'll also show you and how to get started with the ISAT 8008 dataset available through global subset tools. So let's submit a global subset request for the same area and the same subset size. So it'll take some time to finish processing the subset orders. So once the subset are ready, you'll receive an email with a link to the order delivery page. An example link is shown like this here. So the last part of this URL is the order ID. So it has a date and time and location, longitude, latitude of the center and the product name. So now let's download the SDF5 files, which are also compressed as in this file, SDF5 dar.gz. So we'll use this function here to download and uncompress the file. Let's download the SDF5 here. So we are just calling that function from here. So we are passing the order ID and the name of the compressed file to this function. And now So when we have downloaded all the subset files, then we can print it out here. So now we can see here there are 4 ISAT2 ATL8 files in our subset area. So now we can quickly plot the photons height and the classification of that comes in the class PC flag variables of the ATL8 files. So this chart shows the distribution of the photons for one subset file. So the y-axis shows the height of the photons in meters. The canopy top is indicated by the yellow, and the ground is indicated by the brown. And the gray photons are mainly the noise there that goes below zeros and above here as well. So these classified photons can be used to compute several canopy height metrics or models useful for different ecological applications. And the subset order also provides GeoJSON files, so which can be directly imported into your workflow. So as Bruce pointed out earlier, so many other resources are also available to help you use the subset tools for your research. So if you have tutorials or other resources you want to share, or you have further questions, please contact us. So our user support office, the email is provided here. I should be able to help you with your needs. Now I will pass it to Jennifer for the Q&A session. Thank you.
Okay, thank you very much. So I'm going to grab the presenter role back, and hopefully at this point I can open up the polling questions. All right. All right, yes, indeed so. All right, everybody. So we are going to give these about 20 minutes or so, and then we also have some final polls that will that I'll open up in just a moment. So let's get started with the Q&A. What I've tried to do is capture those questions that were also asked in the chat initially. And so the first question is, can you order raw data without applied quality bands and the QA band as a separate product?
So if you use a global subset tool, then all of them will come packaged together. So it will have both raw and filtered and all of the bands that are available within that product. But if you use the API, so you would be able to just request for the particular band that you are interested in. So that will streamline your workflow a little bit.
Okay, great. Thank you, Rupesh. And I think what I'll do is I'll give these questions just only 10 minutes so we have time for the end polls as well. Okay, everybody? All right, so the next question is, what is, and Tammy spoke to this a little bit. I don't know if you wanted to elaborate a bit. What is the advantage of the TESVIS tool suite over a VIIRS? Or perhaps you could, kind of elaborate a bit on that.
Yep, let me
How are they
amplify on that a
different,
bit.
et cetera? Thank you. Thanks, Bruce.
So there's a couple of different factors. One is that these footprint data sets today are not in a VIIRS. They have not, that's I think on their roadmap to be able to do that, but those footprint GEDI data sets and the ISAT would be one difference. There's a key difference too in terms of some of the output formats. A VIIRS will put out data in GeoTIFF and in NetCDF format, whereas we have focused more on those textual formats, the text file, CSV file, and the GeoJSON format. There's nothing in a VIIRS which is directly comparable to the fixed sites pre-extracted subsets that we've got in this. When you get into the global subsets tool, there is a significant amount of overlap. The way of specifying a location is quite a bit different. A VIIRS supports drawing a rectangle and uploading shapefiles. Our methodology is more this center point with north, south, east, west coordinates. And I would say that we make some assumptions that make TESVIS a little bit more accessible to people who don't have as strong a background in remote sensing, whereas the VIIRS tools contain some of the features that are very important to people who are power users of remote sensing data. So I think that would be my answer. Rupesh, would you add anything to that?
Yes, agree with what Bruce said. Our unique feature in the test base is also the pick site tool. So because we pre-process the data set, so you don't have to wait. So if you want to do a very large scale research, like with a lot of data sets across the whole world, so it kind of provides this sampling throughout the world with this 30,000 plus, 3,000 plus sites. So you would be able to grab all those data sets in a matter of minutes. So you don't have to even wait for us to process the data sets, right? So this is a very unique advantage that the test base brings I think when you compare with what they have with the VIIRS. So VIIRS is already a very powerful tool, and it has a lot more products than what our tools offer, but our tools offer a very selected kind of products that are mainly focused towards ecological kind of applications. So that also kind of helps users to sort which products to use, right? So if you just look at those MODIS and VIIRS products range, so there are like hundreds and hundreds of products for each of those categories. So it kind of helps users as well. That's what I find.
Well, thank you so much, Rupesh, and also Bruce. Those are some really good distinctions. And so my next question is, and I'm trying to, if you are asking a question in the chat, if you could be so kind as to also enter that in the Q&A. And if you don't see that on the right side of your screen, you should have 3 dots at the bottom right. You can click on that. And then I think all you would need to do is select, add a check mark next to the Q&A panel. Okay, so the next question is, let's see here. Can I apply the notebook examples demonstrated earlier to all orders from Earth Data Search? And so what I'm doing right now is tackling those questions that I've noticed in the chat, and then we'll skip along down to the questions in the Q&A. So again, the question was, can I apply the notebook examples demonstrated earlier to all orders from Earth Data Search?
So you mean by test phase, the global subset orders? Yes. So if you are ordering a gridded subset order, then if you want a GOT file out of that gridded API orders, so you can use the process outline in that Jupyter notebook, and you can apply to any other subset requests that you have or any products that are gridded. So it will not work if you are calling the non-gridded products like ATL08 or GEDI L4A, but if it's a gridded product, so that approach will work. So if you are ordering not a MODIS, but some other products, like there are SMAP products also available in our APIs. So if you are ordering SMAP products, then you would have to use the EaseGrid projection system, so which is a little bit different from what was shown in the Jupyter notebook, but you can easily you would be easily able to define the well-known text format for the EaseGrid as well. So once you do that, then all the other steps are essentially similar.
Okay, thank you very much, Rupesh. And the one thing I'm not sure whether the tool suite has MODIS aerosol optical depth within it. And so one of the participants' questions was whether or not they could use the TESVIS to monitor and visualize air quality. And so again, I'm not sure if MODIS AOD data is in your tool suite, so I'll let you address that. But certainly there are other tools outside of the Oak Ridge DAAC which could be used to, like Giovanni, to visualize air quality and aerosol optical depth. But I'll let you elaborate.
Yes, I agree. So our tools are more focused towards the land products. So most of the land products we have there, but not the products that are designed for the sea or atmospheric sciences. So they are not there in our tools. So you would have to use some other tools if you are interested in atmospheric products or other MODIS products.
Yes, no problem. And I will follow up with that participant offline with some additional links and contact information. The next question is, using the gridded soil moisture or SMAP data, is it possible to determine, and this might require offline correspondence, to determine a lateral subsurface drainage rate through soil? Can I use SMAP and DAMET data sets together to investigate some site-specific ecological questions? So I think the first question has to do with, whether or not you can use SMAP to, and maybe this is a question more well suited for the NSIDC DAAC folks, since SMAP data is distributed there, to determine lateral subsurface drainage rate through soil. And then the second piece is, can I use SMAP and DAMET data sets together to investigate some site-specific ecological questions?
Yeah, I would say to the second question, I would say yes, right? So you would be able to use the DAMET, which provide precipitation and other meteorological variables, minimum, maximum temperature as well. So you can combine that with the soil moisture data set you get from the and do some cool ecological studies, and people have done that as well. So to the first question, I would say you would have to explore a little bit more if you want to compute those drainage. So right now, all the products in this map will only give you the soil moisture at the up to the 30 centimeter depth. So that's the only thing that you'll get out of it, the soil moisture for each grid, right? So if you want to compute what is the difference, what is the rate of drainage across this grid, then you would have to do additional computation probably. I'm not all familiar with all the products that there is with the SMAP, but there are two products that are there in the test phase right now. One gives the soil moisture, and other gives the carbon as well. So.
Okay, thank you very much. And what I have done is I closed the initial poll, and I have now opened up the end polls, and then we are going to continue forward here with the Q&A. So let me jump now to the questions that were posed within the Q&A. If you could just bear with me for one moment, I'm going to open those up. There's some really excellent questions here. Let's see. Make sure I haven't missed any of the questions here. Okay. So one of the questions was whether or not, and I think my answer is correct, but it'd be good for you to weigh in. One of the questions was, is there a quota of orders per user? And so my answer was, I don't think there's a quota per user, although there's likely a limit as to how many granules you can request in each session. But could you please clarify and add some additional detail to that? Or correct me?
Yeah, so there is no quota for users right now. So if user would be able to submit up to 100 orders at a single time. So if a user choose to submit a lot more orders, probably it will take some more times to process all those orders, and it'll probably also slow down the orders in our servers. All right. So there is no such quota right now, both for the global subset tools and the APIs. But for the APIs, so if you request like more than 10 requests at the same time concurrently, so you will not be able to submit more than 10 requests at the same time. So there is a limit of that in the API, so that some users will not come and then they start to hit our servers with a lot of orders. So there is, for a single IP address can request up to 10 concurrent GET requests. For the API, for the global subset tools, there is no such quota at all.
And that's partly, that's another reason for the Earth data login. So we've got somebody that's making fairly heavy demands on the system that gives us the option to reach out and say, so what's the problem we're trying to solve here? And is there a way which is more efficient for that user and for us to be able to meet a particular user need?
Well, thank you very much, Bruce, and also thank you, Rupesh. And so, let's see here. I'm just trying to see whether or not one of these questions, Bruce, you did answer, but I will just to read this aloud in case there are participants who didn't see this. And then certainly if anyone has questions, please feel free to enter those into the Q&A. So the question was, is it possible to propose or create fixed sites with data sets? And Bruce answered, if you are aware of research locations which are not represented in our fixed sites tool, reach out to us at uso@dac.ornl.gov. And then I do have one. There was another one here. Yes, offline follow-up for SMAP. Not a problem. Absolutely. I'll send an email. Let's see here. We've tackled that. Bear with me here. I feel like I've missed. Well, the one question we could probably have a conversation about for quite some time, but one of the questions was, how is all of this mitigating climate change?
I think the simplest direct answer is that it doesn't, but the more complicated answer is these are tools where people who are doing research can more easily access the data for their field research locations or their other areas of interest to provide greater insight. I mean, there is a little bit of an answer that it does save some time, energy, and effort for us to only provide a user the data that they need rather than a user downloading a large quantity of data and then having to throw away most of it to just get the little bit which is of interest. But the broader goal is that this is supporting both scientists who are doing research that is relevant to climate change and a variety of application users who use this data to help mitigate some of those impacts and understand how things are in fact changing as a result of climate disruption.
Okay, thank you very much. And let's see here. One of the questions was, I think I'm missing just one question. Let me go back here. We addressed the air quality. Maybe we're not missing any questions here. If I'm missing your question, please feel free to. Yes. Are there any high resolution subsets? This was actually the very first question asked, I believe, at the beginning here.
So by high resolution, you mean like daily products? If you mean
this, yes, so if this particular participant is still available and online, if you could elaborate here, that would be useful.
Yeah, if he means the daily products, then we have some of the daily products there in the subset as well. But by high resolution, if he means a very special high resolution,
right?
So MODIS can have only certain high resolution, right? So the highest resolution that MODIS can provide currently is 250 meter. So 1 pixel size would be 250 by 250 meter. So that's the highest that you can get.
Okay, thanks so much. Thanks so much, Rupesh. Yes, and so there was a question, there's, the US is on daylight savings time, and so sometimes it can be a little confusing in terms of the, the start time. So yes, we will be providing a recording, and what I will do, if you have any colleagues who weren't able to attend, I'm going to send the recording link to everyone who registered. And then again, it'll be posted on our NASA Earth Data YouTube channel, and I can enter that link in here. We have over 200, I would say, data discovery and data access webinars that have been held since May 2013. We also have about 4 dozen short data video tutorials as well, and some specialized application workshop presentations like for Delta X and also some ISAT2 actually, workshop presentations. So you could check that out. I don't think I'm missing. I'm just going to take one more look here at the Q&A. Yes, let me see here. I do see that there's more coming in here. 2 questions sent to Rupesh. I don't think I'll be able to see those. So Rupesh, if you have a couple of questions that you could. Don't think you can click in the Q&A, click on my Q&A perhaps, and that should help you identify them.
Yeah, there is 2 questions I see, Steve. So one says, how does a global subset deal with multiple fractional data pixels within a user-specified subset area? Multi-tile fractional data pixels. So, yeah, so if I understand this correctly, so global subset tool will compute those multi-tile areas and then put them together as a mosaic for a whole subset area. So that's how we process all those multi-tile fractional data, and data pixels will be preserved as it is from those tiles. So we will not modify the values of the data pixels at all. And there is another question that says, how can I get pixel maps or grids to use in Google Earth for exploring a landscape for topographically uniform pixels? Clearly, for some reason I specify. Yeah, so there are various tools that can export GOT file, for example, into a KML file that Google Earth can read. And I think now Google Earth also support importing those GOT files directly into their software. So you would be able to just download the GOT files that you get from the global subset tools and then import them and visualize in your Google Earth software directly.
Okay, thank you, Rupesh. The next question is, does this tool also provide functionality to search and list all available data in a region of interest, or do we have to know the data before submitting a request?
Yeah, it's always a good idea to know about the data, right? So for example, some of the data will, there would be no coverage for example, GEDI. If you look for the north of 52-degree latitude, then you would not have any coverage at all. So there is some check in place in the tools that will not let you order the data if there is no data available for that area. But sometimes those checks might fail. So it's always a good idea to know your data first before you submit the ordering. And that way you will also know how to apply the quality flags, and you also know about those constraints of the data sets. So all the data sets have issues with it, right? So and then you'll also know what issues that you would already have to address if that fits your user's need or not. So it's always good to start with the data user guide and then also read the algorithm document or ATBD, and then you come back to the tools and then start submitting the orders for your study area.
Okay, thank you very much, Rupesh. I do not see any additional questions at this point in time. So if there are no additional questions, what we'll do is we'll leave the virtual meeting space open an additional 10 minutes from end time here. So if you think of anything or you'd like to respond to the optional final polls, please feel free to submit your input there. We really appreciate it. It's super helpful in identifying future webinar topics and also in recognizing where there may be knowledge gaps or data user needs that the data centers can address at some point in the future. Right, so user feedback is extremely valuable, and we really appreciate you taking the time on those. So with that, let me just do one more scan. I will look in the chat as well. I think I've captured all of the questions from the Q&A. Let me just do one more. Yes, I don't see any additional questions. And here's a question that comes up quite frequently, and so I'll address it here, although I'm sure I'll receive some emails. We are not, at least not yet, we're trying to work through this process at a NASA level, offering a certificate of completion for our Earth Data webinar series. We're in the process of getting something like that going, but it is not in place yet. There are some details that are still being worked outside of my team. And so when that is something that's available, perhaps we can retroactively, you know, email a certificate of completion or participation, if you will, for this webinar. But at the current time, that is currently not in place. And so I think with that, I am not seeing any additional questions. I'd like to thank all of you and all of our speakers and our ORNL DAAC panelists, Tammy Beatty, Michelle Thornton, our speakers, Rupesh Shrestha and Bruce Wilson, and my co-host, Geraldine Tuart, for all of your help and your content this afternoon, and thank all of you for taking time out of your day to join us. So with that, we'll log off from the audio component, and I'll leave the virtual meeting space open. If you think of anything, I'll be here, and you can certainly email me as well, and I will make sure that the speakers have any information they might need, and they can follow up with you offline if needed. All right, well, thanks so much, everybody. With that, we will log off from the audio, and I'll leave the virtual meeting space open. All right, take care, everybody. Goodbye now.